Did I do those circles up there? Oh, no, because I couldn't reach it. You could see somebody tried to erase one and was unsuccessful. I accidentally wrote on one of these screens, so.
What room?
Upstairs in.
Is that our operations class?
Is that a C on it?
Yeah.
Yeah.
Don't,
we're just
don't rat me
joking.
out. Yeah, don't rat me out on that. That was an accident. I was doing just what I'm doing here. I went in, and I'm like, oh, no. And then I tried to erase it, so there's probably, it's going to look a lot like this. It's a smudge because I tried to erase it and it didn't erase. So you guys got that room too?
Yeah.
That's awesome. Yeah, it bugs the crap out of me. I want to complain.
Someone wrote on that. What an idiot.
We should get that guy fired. Give me a petition, I'll sign it. I'll be the first one to sign it. All right. Yeah, that was me. Sometimes you just lose track. But I've said this before. Why they don't have just writable screens in the first place? Why isn't the whiteboard the projector screen instead of me having to pull it up and down? Any questions? Pretty simple stuff. Pretty basic. But again, it's still mind-boggling what we're doing. We're measuring the effects of promotion on the probability of purchasing Heinz using a binary probit model. I mean, just try to say that. That's hard enough to say, but we're doing it. I mean, I think that's awesome. And I think I told you this data is really expensive. This home scan data, because it's different than the scan data which you get from the stores. These are families that are contracted to actually go home and scan their groceries every day, or whenever they shop. Remember that one of the big issues in the promotion was that, at least that I brought up, was that this one assumes that these lines are parallel, that there's purely a dummy in there. And I said in the paper, in my paper, I said, well, these could differ. So this line might be, this line with promotion. It would make sense. It wouldn't be that outrageous if we said that people that buy on promotion are more price responsive than people that buy off promotion. So we basically created an interaction. And we're going to do the same thing with the probits. So we don't want to necessarily assume that the S-shaped curves are kind of a pure shift. We want to allow the prices to, the elasticities or the price sensitivity of consumers to differ between those two. So we interact them. Remember, interaction doesn't force them to be different. An interaction allows the slopes to be different. So if there is no difference, they'll still look parallel. If there is a difference, however, we've allowed it. And again, it's important to just kind of remember the basic econometrics of it. If we were doing a linear model, so this is cases, whatever, equals beta 0 plus beta 1, price plus beta 2, promo plus UI. This is a pure shifter. A dummy is a pure shifter. The only graph you're going to get from a pure shifter is two parallel lines. It's literally impossible to get anything else other than two parallel lines from that model. The only way we're going to get lines that differ in terms of the slopes is to add that interaction. So beta 3 is going to be price times promo. And that's going to allow the slopes to differ. Again, it's not going to force them to differ, but if they do differ, it's going to allow them to differ. So to do that, we're going to follow the same logic that we used in linear demand curves with our binary demands. And here we're going to make use of the factor variables. So instead of constructing a I'll try not to write on it. Instead of constructing a new variable, which is relatively easy, it'll take us 10 seconds to do it, interaction between price and promotion, we're going to make use of factor variables. So we have to designate price of Heinz as a continuous, that's the C. We already know IDOT is for our dummies or indicators. And then the double hashtag is construct both dummies and interactions. If we only put one hashtag, it'll just do the interaction. Yeah, it'll just do the interaction. But the two hashtags will construct the dummies and the interactions, which is what we want. So our results, we still get price. This is the dummy. And then this is the interaction. This is, it tells us it's a feature times price. It's the interaction. Notice the dummy is indicating that the intercepts, remember it's the intercept, or the change in the intercepts, are not necessarily statistically different. That's not necessarily a bad thing, because remember that these binary demand curves, or these low-jet appropriate demand curves, they're almost forced to have the same intercept, right? Because they're always going to go to 1 and 0. So even if there's a huge shift, so let's call this a huge shift, even if there's a huge shift, where's that intercept going to go? It's going to go pretty close there, and it's going to go pretty close there. So not having a significant difference in intercepts is not that big a deal, especially in these probit demand curves. What's probably more interesting is there doesn't appear to be much of a statistical difference in the slopes. Our t-stat's not real low. It's marginally significant, I guess, or let's call it marginally insignificant. If we get rid of that 5, it would be significant at a 10% confidence level, significance level. But right now, it's not significant at 5%. It's not significant at 10%. It would be significant at 11% significance level if we really wanted to argue. But more than that, I think what we want to see is, are we getting these pure parallel shifts, or are these curves, is the curvature changing between these two? And that's what we want to do in our graph. Because remember, these are nonlinear, so the effects are going to differ. So we still want to graph these. We're going to run the same command. Thinking, doing the math, and does that look different than the first one? Yeah. I think so. Because you can see that, interestingly, very interestingly to be honest, is that promotion has a bigger effect at the higher price, which is strange. It's usually the opposite. But remember, this is a strange market because there was, at least at this time, there was really only 2 dominant players in this market, Heinz and Hunts, or 2 players in this market, Heinz and Hunts, and Heinz really had, is it what, 90% of the market? So yeah, the slopes do differ, which is nice. And again, a lot of that is hard to convey using regression results or tables or anything else. And it looks like, well, the curve stretches out a bit. So the slopes look like they're going to differ. We could measure these differences. Here, here, and here. We can have static measurement. So we can do something along the lines of, did I jump? Yeah, so I might have jumped a few margins. No, then we're going to measure it at a specific price. So let's go back to our graph there. Get rid of the graph. All right, it looks like we're going to measure it at about 6 cents, so hopefully here. So let's measure the effects of promotion at 6 cents. Remember, they're going to differ, so we can construct a table using margins. using the at function. That's not what I want. Do that in a minute. This is what I want. Oops. Oops. Yeah. Okay, so what's the effective promotion at? Do not erase. Do not erase. Okay. Let's scroll down a bit. All right, I'll put these things in the same frame. All right, not too high. Let's see if everything matches. All right, let's see if everything matches. At 6 cents, and again, we don't have 6 cents in here, so we probably want to increase the units. But at 6 cents, it looks like the probability off promotion is 31 cents. I'm going to write on the wall. So we won't do that. Again, yeah. But yeah, it looks like at 6 cents, the probability where is it? It's 31. So right about here somewhere. And then when Heinz is on feature, the probability jumps up to 71. So it's at 6 cents, there's a pretty good, so the difference between the 31 and 71, 40 cents, I'm sorry, 40 percentage points. That's a pretty big jump. You're increasing the probability of someone purchasing your product by 40 percentage, not percent, but percentage points. You're going from 31 to 71%. Probability. So that's a pretty big boost. That's a pretty big boost. And again, it's going to differ at different prices. What we're going to want to be able to do, just to give you a teaser as to what we're going to get to, if you remember Tableau, Tableau is going to give us the ability to to actually do these calculations on the actual graph. So we'll be able to, so this will be in Tableau, and we're going to be able to hover at 6 cents and find that probability, and then hover and then save it and click it again on the other feature graph and find its probability. So we won't have to use margins to actually calculate those probabilities. You'll be able to literally see them on the graph. That is going to be awesome. Excited. I can't wait. We gotta wait. Is that cool? Is that I mean that seems, like I said, that's awesome. That's cool. All right. Stop talking. Let's get going. One of the things that what the other command was that had the dydx was comparing not the probabilities at 6 cents, but comparing the slopes. And the slope, again, tells us how sensitive consumers are to small price changes. So we can compare the slopes, and again, it looks like the non-promoted demand curve, we'll call it that, is steeper, so it's more sensitive than the promoted demand curve, which is opposite to what we got in the previous results, but let's double check that. So let's go to the command here, and again, the only thing I changed was I added that dydx, and I want to evaluate it at price, which is our only dependent variable. And And again, it's gonna give us, it's negative because it's the slope and it's downward sloping. And it confirms what we visually saw, which is that the slope of the non-promoted demand curve, when features equal to 0, is 27, meaning that for a small increase in price, the probability of fall by 27%, and for a 1 cent increase in price, I mean 1 cent is a big deal, you'll get a 27% decrease. But on the featured one, when Heinz is on feature, a 1 cent increase will only decrease the probability by 16 percentage points. So we see that the consumers are much more sensitive on the non-promoted demand curve than they are on the promoted demand curve, interestingly enough. We might investigate that also. Let's throw everything in. So here we've got, we don't want to have to do these individually, so we're going to throw all these in at once so we can evaluate feature, display, and then the joint feature and display. We're interacting everything, so we're going to have dummies and interactions. We're double hashtagging everything, so we in the Twitter terminology. So we got, again, coefficient on price is about the same, 75, it's been 75, 77. Our dummies, and then these are our interactions. This tells us feature, price, display price, and then feature and display price. And we'll take a look at the graph and see what that looks like. I think this was for an older version of Stata though. So Stata 14, and by the way 15 is out, but Stata 14 didn't have as flexible of a memory management as the newer Stata. So let's see what we got. So we have dummies and interactions, and I left out the legend for a reason, because it gets confusing. We want to make sure we label things correctly. Label promoted and non-promoted and which promotions. So here I left out legend. I think I just didn't include a legend. So I changed the label size in the legend so I can read everything. But there is no legend here. And again, the reason I did that was so I can construct a legend and know exactly what I'm graphing. So, feature 0, display 0, feature and display 0, that's our blue one. So our blue one is our base. It's our non-promoted category. Our red is going to be feature 0, display 0, so red is feature and display, which is the next one. And that's how Stata goes. It goes left to right just like we read. The green dotted one is going to be feature 0, it's going to be display. And then the yellow mustard, whatever that is going to be featured. So this is the, Stata is going to give you an idea of what each of these graphs is. Then we just construct a nice legend and make sure everything's right. Now we can set up our legend. First one is without promotion. For some reason I changed the order, but you can do that. I guess that's probably why I did it. You can do that. Because this is going to be in order of that the variables were listed in when I didn't have any legend on there. So I got feature first, then display, and then feature and display. So 4, 3, and the two. And let's see what it looks like. I don't know why I changed the order. I was just in that order changing mode, I guess. But you can change the order to anything you want. What's interesting here? What should be baffling you?
Feature and display.
Is the worst. It's also the most expensive. So remember that, we're gonna come back to this later on. We're gonna try to answer this, because this is a big deal. The promotion that costs us the most is having the least effect. And if we did a test, and we're actually gonna do a hypothesis test, we're gonna actually test whether this profit demand curve is different than the promotion one, whether the feature and display one. And it looks like they're not any different. So, but yeah, that should be concerning to the firm, that they're spending all this money and they're getting zero return on their investment. This is a ineffective promotion when it's, remember what feature is. Feature are mailers that you gotta mail out. You gotta print those suckers up, you gotta send them out, so that's expensive. And then display is in-store stuff. So you're doing both these things and you're not getting a damn thing out of it. You're not getting any effect out of it. So that should be truly disconcerting. We're going to try to answer this, but that should be truly disconcerting. The other ones look normal. I mean, why would feature and display not work, but feature works individually and display works individually, although features, it's getting a bigger impact. We'll find out. But this is the kind of thing that you investigate when you're analyzing this kind of stuff. Any questions? I love this stuff. This is, yeah. Anytime something weird comes out, it's just, like I said, I didn't make it up. This is actual data, so anytime we can solve a mystery, I'm solved. We can throw in these confidence intervals. I think I showed you before. This is going to be a mess. Remember, the wider the confidence intervals, the less confident, well, the less confidence you have in those estimates. Look at those confidence intervals on feature. They're out there. The blue, the non-promoted demand curve, our base non-promoted, pretty narrow confidence. So we're pretty confident in our non-promoted demand curve. There's a lot more noise and a lot less confidence. Look at feature and display. That goes all over the place, and display, also. So these results are a bit noisy, and that should, we should worry about that. It might be sample size. We don't know how many observations for each of these we have. I guess we did. We looked at it, but we'll investigate that too. You never want to show this graph. This is just a mess. But it does tell you that this stuff can get messy. Now, we really already did this, but one thing we have to be careful with margins is it's extremely powerful, but you really have to specify what's going on. So I'm actually going to skip this and go to so that's going to be all together. So that was just to show you that these things. price elasticities, I think we did we do this? Let's run our probe it. Got our interactions. The margins. And this. Do our probe it. The syntax for this is dy dx is the slope of the function. We already did this when we evaluated it at 6 cents between the promoted and non-promoted. So dy dx is going to give us the slope. This is an average slope. Remember, the slopes differ, so this is at the average. But we can also get what you might call a quasi-elasticity. Remember that elasticity, price elasticity, is the percentage change in quantity demanded over the percentage change in price. And that's our definition of a price elasticity. That's the literal definition of a price elasticity. We normally don't like to do price elasticities in this. I mean, we could, but remember that our slope is the change in the probability that we purchase Heinz over the change in the price of Heinz. This is the slope. If we were to convert this to an elasticity like we did here, then we would get, we would just add those. And now remember, this is a probability, so it's already kind of a percentage. It's 0 to 1. So now we would have a percentage of a percentage, which is awkward. So a 1% increase in price results in a 5% increase in price. The price is already in percentages, so to me it's an awkward interpretation. So what I like to do, if you're going to look at an elasticity type of figure, is leave the numerator in terms of probabilities and look at the denominator in terms of price. And these I call quasi-elasticities. I needed a term for it. It's not really an elasticity. It's kind of an elasticity, so it's a quasi-elasticity. Remember how we did these? How do we find elasticities in ordinary least squares regression? Took the logs, right? We got that? Stata will actually do that for you automatically. All you have to do is tell it. Don't you wish you had all these commands in 580? So to find this quasi-elasticity, we're going to use either grow a few inches or we're going to use the dy, which is the change in the numerator, but instead of dx, we're going to use ex. And ex tells Stata to convert that into a log, take the derivative, and give us the result, and give us this quasi-elasticity. And notice it's, again, it's different. So for a 1% increase in price, the probability of purchasing Heinz is going to go down by 44 percentage points instead of 44%. Again, it's not going to be a percentage. So that's a little bit more intuitively interpreted. Now we could do a pure elasticity, and it will give it to us if we change both of those to e's. EY-EX would be kind of a pure elasticity. And again, this has a somewhat awkward interpretation because now it's a 1% increase in price is going to reduce the probability of purchasing by 0.64%. Not percentage points, but 0.64% of a percentage point. I mean, like I said, it's an awkward interpretation. So I normally don't like elasticities when we're dealing with these probit demand functions. If I'm going to look at some sort of an elasticity, it'll be this quasi-elasticity. But in all honesty, I like to simply look at the slope, which is how price changes the probability. So, remember, one of the reasons we looked at elasticities is we can compare. If we had one product that was selling 10,000 cases a week and another product that was selling 50 cases a week, it's hard to compare the slopes because an increase in price would seemingly have a much bigger effect on the higher volume one. So we converted them to elasticities to kind of normalize it too. We don't have that problem here because in both cases we're looking at price changes, the effect of price changes on probabilities of purchasing. And the probability of purchasing any products are always going to be between 0 and 1. So we don't have the problem of comparing different units. Right? Remember that? And that was the whole purpose of elasticity, was to normalize price sensitivity. We don't necessarily have to do that anymore.
So I might have missed this, but what's the difference between the dyex command and the dydx?
So dydx gives us the slope, gives us this. Dyex gives us, the top is still, dyex, still the top is the probability, and then it gives us a percentage change in price. So it changes that.
This data does everything for you.
Cooks and cleans. Does it all. Okay, here we're evaluating at specific prices. We can do that. Here's the model we just ran. And here we're going to include everything. So we got price. We got all the promotions associated with Heinz. But we also know that the price of Hunt's is in here, and we're going to have the promotional aspects for Hunt's. So what we want to do is include everything. If you're Heinz, you want a model that's going to include everything that's going to affect my demand. So we can call, right,